back with Math Chapter 10. You are going to need a couple things today. You're going to need this transparent mirror that should have been in your book box. You're going to need your math journal. You are going to need this piece of paper from your packet, the clown paper from your packet, and this kind of funky looking drawing paper from your packet. So I will let you get those out and turn to page 274 in your math journal. It says that you're going to work with a partner, but you really don't need to do that. You are going to take one transparent mirror and read journal page 274 and then experiment with the mirror and see what happens with that mirror. All of you have kind of been wanting to know what that mirror does. Here's the basic use of a transparent mirror. A transparent mirror is shown at the right. We know that the word transparent means that you can see through it. Notice that the mirror has a recessed edge or recessed edge. It kind of goes in right here. You can feel like that little edge right there. It goes in a little bit, along with which lines are drawn. Some transparent mirrors have a drawing edge both on the top and the bottom. In other words, they wouldn't have a recessed edge. Place your transparent mirror on this page so that its drawing edge lies along line MK below. Then look through the transparent mirror to read the backward message. So this is kind of a secret code or a secret message that you're going to be able to read after you use your transparent mirror. You would put it right here, and then you're going to kind of have to experiment as to how you're going to read that. You would be on the opposite side if you wanted to read this. I'll let you do that. I'm guessing most of you have figured out by now what the message says. If you would follow the directions correctly, you are now able to read this message. Here are a few things to remember when using your transparent mirror. Always look into the front of the transparent mirror. In this position, the drawing edge will be facing you. Use your transparent mirror on flat surfaces like your desk or your tabletop. Use a sharp pencil when you're tracing along the drawing edge. Experiment and have fun. So we're going to do a whole bunch of little activities today with the transparent mirror. And we have kind of a short lesson today. We are going to explore with the transparent mirror today. First of all, I would like you to get just a blank piece of paper. If you don't have one, you can also look in your game packet. There's tons of blank pieces of paper in between the games. So if you would take a half a sheet of paper and draw a squiggle on that sheet of paper. So just a half a sheet, draw a squiggle anywhere on that sheet of paper, maybe toward either one edge or the other will make it better so that you can see the other half. Then you're going to place the transparent mirror so that the squiggle is between you and the mirror. So that the squiggle is between the mirror and your eyes. Look through the mirror and tell what you see when you look through that transparent mirror. I bet you're thinking, wow, here's your pre-image that you drew. And when you look at the image through that mirror, it looks like it's a reflection. It flips. The original squiggle is known as the pre-image. The squiggle on the other side of the transparent mirror is called the image of the original squiggle. The image and the pre-image are congruent. Congruent means same size, same shape. Same size, same shape. Now move the transparent mirror around and observe what happens to the image of the squiggle. Does it move with you? What does it do? All right, so you should have found this in your packet of papers. This would be in the packet that you picked up last Friday. It has 10.1 at the top and the word buzz, and then it's got a bee right here and a beehive. What your job is, this is just a little exploration. You're just going to use your transparent mirror. Beatrice the bee, here she is way down here. I'll adjust that so you can see her. Beatrice the bee right here. She wants to gather pollen from each of these flowers on here and then return to her hive. I would like you to use your transparent mirror to help Beatrice follow along or fly around. So you're just going to use your transparent mirror, put your paper on a tabletop, put your transparent mirror in front of Beatrice, right here, and then use it to squiggle around to each one of these little flowers right here and see if you can get her to fly to each of the flowers and to her hive. See if you can experiment with that transparent mirror. This is all this lesson is going to be, is experimenting with the transparent mirror. Because A, it's fun, and because B, it has something to do with one of the concepts that we're going to be doing in a couple of days. So I would like you to take 5 minutes right now. Just use your transparent mirror. See if you can get Beatrice the bee to cruise to each of those flowers and to the hive. Alrighty, I'm hoping that you took your 5 minutes to check out Beatrice the bee, and hopefully most of you got that to work. So you're getting pretty good at using the transparent mirror. Same thing. Now you should have a clown paper that also should be in the packet that you got from us on Friday. It looks like this. Has 10.1 at the top, build a clown. It would be in a stapled packet, just like the other one. Use your transparent mirror to put a hat on the clown's head. When the hat is where you want it, draw the hat. Do the same thing with the other missing parts to complete the clown picture. Then color the picture and cut it out. You don't need to color it or cut it out because we did these back to back. So you can choose from a couple of different hats. There's the flower hat and the Dr. Seuss hat. You can choose from a couple different mouths, and you can choose from a couple different noses. So you choose how you want to make your clown and what he's going to look like. Remember to use your transparent mirror. Move it around so that you can get, if you chose this nose, so that this nose would be right here. If you chose this hat, the hat would be up here. You're going to have to use that transparent mirror and get really good at it and try to move it around in order to move those pieces or those missing parts for the clown. I'll give you about 5 minutes to hang out with that. This is crazy because this is pretty much our lesson for today, using that transparent mirror. So if you would get really good at that, then our lessons go much quicker. I'm hoping that all of you figured out the transparent mirror, how to move the pieces onto the clown or to the missing parts onto the clown. If you didn't, keep on practicing. Right now I would like you to turn the page in your math journal to page 275. We are already on math boxes. That's pretty wild. Number 1, you're going to use your geometry template to draw the image of the figure that is shown on the right of the line of reflection. So here's the pre-image. It's already drawn for you. That prefix pre means already done, or done something before. Here's the line of reflection. This is where you're going to put your recessed edge of your mirror, that indented part of your mirror right here. I'm going to put that right there. And then while looking through it, so you'll be facing this way, you'll be able to see the line of reflection and you'll be able to see the shape on the other side. So you're going to use your geometry template and see if you can figure out how to draw that. Number 2, the following totals came up when Tina threw 2 dice. So she's got 4, 5, 9, 6, 12, 12, 2, 5, 6, 12, 3. You are going to find those landmarks. Aha, you don't have a poster to look at, so you're going to have to try to remember or look it up as to what these mean. The median, we did lots of those with your head sizes. I can't remember exactly what else. What did we do? Head sizes, how tall you were, I think. Different little things where we lined all of you up, put you in order, and then crossed off from the ends or had you sit down and figured out the middle number. The mode is the one that you see the most often. In other words, is there a double up there? Is there a triple up there? Letter C is the maximum. What is the largest number up there? And letter D is the minimum. What is the smallest number up there? Last one is the range. You're going to take the maximum and subtract the minimum. That will be your range. Number 3, you're going to order the fractions from the least to the greatest. Remember, if you have common denominators like all of these, you just have to think of, I'm dividing a pizza into 7 parts. If it's my favorite entire pizza of the entire world, Would I rather have one of those parts or would I rather have 8 of those parts? List those from the smallest to the greatest or to the least to the greatest. If you have a common numerator, you're going to have to do a little bit more work. Think about which piece would be the smallest. This is going to be the opposite of this one. Look at 2 12ths. Cutting a pizza into 12 parts, you get 2 parts. Cutting that same pizza into 3 parts and you get 2 parts. So think about it that way. This one's a little trickier. I always think of, first of all, I want to know, if there's anything that's equal to half or close to half. I do see a half right there, so I'm going to do this one right below here with you. So you should be getting this one right. Half goes right there. Okay, is there anything that is less than a half? Well, I know 3/5 is more than a half because 2 1/2 is half of 5, so that's more than a half. That's going to go on this side. 9/10 is also more than a half. That's also going to go on this side. What about 4/9? 4 1/2 ninths would be half, so that's going to go on this side. And 2/7, that's less than half, so that's going to be going on this side. We have to determine which one of these is smaller though, 2/7 or 4/9. If I'm not sure, I can always butterfly. 2/7, 4/9. This one's really close to half. This one's not even close. I already automatically know that this one is probably going to be smaller than this one. But let's just do the butterfly just to double check. Remember, we create those wings, and we have 28 over here, and we have 9 times 2 is 18 over here. So 2/7 is smaller than 4/9. Then we have 4/9. Then 1/2. Then we have to decide between 3/5 and 9/10. 3/5 is over 1/2, and so is 9/10. Let's do the same thing. Let's just butterfly it just to make sure. Butterfly wings, butterfly wings. So we have 45 right here. 9 times 5 is 45. 3 times 10 is 30. That means 9/10 is larger. So we have 3/5 and 9/10. Since I did this one for you, you should be getting that right. Next one, number 4, insert the decimal point in each product. Oh my gosh, these are so easy because it's multiplication. Remember, start on the right side of the number. I have moved my decimal point over 1 space. So if I started on the right-hand side of the number, move your decimal point to the right. Okay, right-hand side of the number, I have 4.96. I start right here, move it over 2 places, 1, 2. Do the same thing in my product. 1, 2, decimal point right there. See if you can figure out these next 2. Looks like you're going to move it over twice here, over twice there. Number 5. Miko took 40 shots in the basketball game. She missed 30% of the shots that she took. What fraction of the shots did she miss? So we have to figure out, she took 40 shots in all. That's quite a few. But I want to know what 30% of 40 is. So 30%, I know that I can break up 30% into 10% pieces. So if you remember our little trick for doing 10%, 10% of 40 is 4. So that means 4 is 10%, 8 is 20%, and 12 is 30%. So that means she missed 12 of her shots out of 40. 12 out of 40. 12 out of 40 there, or 30 out of 100. Same thing. How many shots did she miss? She missed 12. All right, and perimeter is the distance all the way around, so 18 plus 3 plus 18 plus 3, and the area is base times height. That is your lesson for today. We are going to look a little bit more about transparent mirrors in our next lesson.